Well, last time we were talking about debugging, right? And we've all probably come up with our own strategies at this stage. And some work better than others. And it often is the situation, pardon me, when debugging complex problems, which your problems are getting more and more complex as we go along in the course. When you're debugging these problems, we have this tendency to refuse following a rigid strategy for debugging because we could totally figure it out on our own. But the problem is you can't, and that's why you're there in the first place. So you need to come up with a good way to debug. The easiest way, easy is not the right word to use here. The simplest, most straightforward way that I would recommend for debugging is just throw print statements or print functions everywhere. Throw in a print. Right? You know what your function's supposed to be doing. You hit run and it doesn't work. Well, why? Well, you know how it's supposed to work, so throw in a print somewhere. Did it do what it was expecting at that point in time in the code? If it did, good. If not, well, you've got a problem around there. If everything worked fine up until that point, move the print to somewhere else, and so on and so on and so on. So, for example, let's work through this right here. If I go here, I'm just going to delete this. I wrote a function sum up to. It's supposed to take a number and then add up all the numbers from 0 to n exclusively, not counting n. So if I say 5, I want 0 plus 1 plus 2 plus 3 plus 4, not including 5. So that's what it's supposed to do. And I wrote this code, everything seems fine, except it's not. When I do 0, it worked, but when I added 5, it didn't work. Well, why? Well, I obviously can't tell what, the answer's supposed to be 10, but what did I get? Well, I don't know based on this, so let's call it and print out the result. So, here, let me do this. So here's my first print. It's not even in the function. Print, okay, I got 15. All right, well, yeah, that's definitely not 10. So where's the issue? Okay, well, okay, look. Up until this point, okay, look, I know this looks silly, but print. I know it looks silly, but let's just make sure we're not crazy, right? I'll throw a print in there, hit run. Okay, 0, 0, okay, yeah. Everything seems fine, and obviously we see it printed out twice because this function got called twice. So in fact, I'm not even interested in this right now. Let's get rid of that. So we see 0, 0. Yeah, that makes sense. I hit run, the total should be 0, and the counter should be 0. Okay. So clearly the issue, it doesn't really seem like the issue's here. So, I don't know, print. Let's put it there inside the loop. Okay, we see, all right, well, everything seems fine, I guess. First time through the loop, we have 0 and 0. Right? Total 0, C is 0 before we do anything in the loop. Then we have 1 and 1. Well, yeah. And then 2 and 3, and 3 and 6, and 4 and 10. That makes sense. Everything makes perfect sense. Where's the issue? Right? To be clear, first time through the loop, why do we see 0, 0? Well, C was 0 and total is 0. And what do? We add 1 and we add C to the total. So the next time through the loop, C is 1 and total is 1. It's because it's 0 plus whatever C is. Next time through the loop, it's 2, and then 2 plus 1 is 3. Next time through the loop, C is 3, and then 3 plus 3 is 6. And the next time through the loop, C is 4, and then 6 plus 4 is 10. So everything seems fine. What's going on here? Well, we could try moving the print. I don't know, down here? Ooh. All right, well, okay, I'm seeing something here. We should never have allowed C to get to 5. Yet clearly C got to 5. How did that happen? Like what's going on here? How did C get to 5 and then 5 get added to the total? What's going on? Like now, what you should see now is by moving that print function around, I'm starting to be able to narrow down where the issue is. So it seems like, okay, how? So we added, so how is this happening? Okay, the difference between this and the last is, the last time I ran it, the print was at the top of the while before anything in the loop ran. Now it's at the bottom of the while, well, everything in the loop ran, and then it prints. And I can see that we allowed C to increment, and then we added total to C. I think I might see the problem. Raise your hand if you think you see the problem. Couple people? The problem is that I'm incrementing C. C is the counter. I've incremented C before I added it to the total. I shouldn't have done that. I should have added the current value of C to the total, then increment C. So let's move this around. And there we go. C did become 5, and that was fine. But C became 5 on line 6. We go down to line 7, we print out, is that line 7? It's hard to tell on the angle. Yeah. We print out C, well it's now 5, but total never had 5 added to it. Then we go back up and we say, hey, is 5 less than 5? No. Oh, we stop. So there we go. With the use of print, I was able to, I had to move the print around. I was able to narrow down where the issue is. Now this is an example of me using the print to print out the current values of things, and sometimes that makes perfect sense, like here. But sometimes it doesn't, you don't even need to be printing out the values of things. Sometimes you just need to be like, did the code, like this if statement should have been true. Like it should have evaluated to true, meaning this block of code should have ran. So I just need to add something, like imagine the question is like, is this loop even running? Yeah, I can print out the values of C in total. But imagine if the question is like, is the loop even running? You just throw something like that in there, oops. And we, oh, okay, yeah, it's running. Like I didn't even need to print out a value. The string hello is a value. I didn't need to print out any of the changing or like mechanical values here. I just printed out something to know like, okay, that code did run. I did go inside that while loop, good. But be careful, and I'm giving you this warning because my code, like when you're done with these prints, get rid of them. Because you don't need them anymore, right? You don't want to litter your code with print. And programmers have a really bad habit of never deleting a line of code because they're always like really like conservative about like, well, maybe I still need that. So they'll like just, comment it out. They're like, yeah, maybe I need to throw it back in there. But chances are you don't. If you don't need it, get rid of it. And this isn't that big of a deal, but the problem is if you go look at my code from when I was a student, I would have things like, and this can upset the TAs. So just, be careful a little bit. But print, there, with print, we were good. Print kind of helped us figure out where the issue was. And I don't, like, it's a bit of a joke, like, oh, you debug with your print functions. Yeah, because it's damn good and easy to use and it's straightforward if you understand how the code should be working. So print, has anyone been using print as a debugging tool? If you haven't, you should be. It's the easiest, most straightforward way to do it. But there's no guarantee it'll help you find the problem, but it's a hell of a lot better than doing nothing and hit and run over and over. Yeah, so the process follows a typical pattern. Form a hypothesis about what you expect the variables to be at a specific part of your code. Add a print and print out those values. Hit run, compare your expectations to reality. If they match, the problem might be elsewhere. If they don't, interesting. Let's follow that brainwave. If they don't match, yeah, investigate why they differ. Each print enables us to form a new hypothesis and continue debugging. So there you go. Just follow that process, you're in great shape. Depending on the complexity of the problem, you may need a lot of prints in order to make any progress. The next step is pencil and paper. And a lot of people hate this, but it's damn good. People are resistant, like I said, they're resistant to go through these strategies, even though chances are this will help you solve your problem. Here's also why it's good. When you do it with pencil paper, it slows you down. And another thing is often when debugging, it's very easy to make assumptions about how your code is working. Well, okay, this line of code does that. Does it? Okay, this is a function call that's going to, does it? Because your code's broken, and you're making assumptions that it's working. What? No. Assume none of the code is working. Every line you have to be suspicious of, no matter how simple it looks. Always be suspicious of the lines of code, because your function's broken. So never assume anything about your code. So when that's a rule in general, but when you're debugging with pencil, because it's slowing you down, people find it easier to make less assumptions about your code. And this example, this strategy of debugging is like, what does the code say? I know it feels like, oh, I don't need to actually I know how it would. No, you don't. What does the code say? Line by line, what is it doing? And if you think, well, how am I supposed to know what it's doing? Well, you wrote it. You better know what it's doing. So don't assume anything. Don't assume any variable has any value. Just take your time, grab a sheet of paper, a pencil, and start keeping track of the follow it line by line, updating the variables on a piece of paper with your pencil. That's how you're going to do it. And you execute the whole code by hand. And you'll be shocked how good this goes. And it always goes the same way. I know how this goes, well, I'm going to do it anyways. All right, so on this line here, we can see that, okay, n is this, then is that. Then on this line, yeah, we add them together, yeah. And then on this line, I see. That is the common pattern. Like in the case of using print. Okay, what did I say? It's easier said than done, especially when depending on running your code. Yes, so the whole thing about like assuming how your code works, that's really easy to assume what your code's doing when you just hit run. A workaround is to not run your program on the computer, to run it on you instead. Execute the program on paper. The benefit of the approach is it slows you down, it's easier to not make assumptions, and it requires you to be very deliberate and thoughtful with what you're doing. It may sound tedious, but I mean it is, but at the same time, what do you want to do? Do you want to spend 4 hours debugging this code or spending 4 minutes executing it by hand to save yourself 4 hours? Like it's a common joke, but that's what it always comes down to. Note, the point here is to take your time and think about every line of code. Rushing through making assumptions will obviously fail. Remember, you are here in the first place because your program is broken. So assuming it works is a stupid thing to do if you know it's broken. Yeah. And then delta debugging. This is perhaps, it's not as clean, I don't know. I'll withhold adjectives. Here's what you do. You write your function, it doesn't work. First of all, if you're writing your functions well with really good code, your function should never be huge, right? They should be relatively straightforward. What you do is you start by deleting your function. You delete it. Maybe you delete everything but the signature line, and you hit run. Did it work? Well, it's not going to do what it was supposed to do, but will it do what it's saying to do now by just having like an empty function? Yep. Add one line of code. Hit run. Does it work? Add another line of code. Hit run. Does it work? What I mean by does it work, I don't mean does your whole if your function is supposed to take 10 variables, add them together, divide them by whatever, do all this stuff. I don't mean does it do that after 2 lines of code are added? No, I mean does the 2 lines of code you added do what those 2 lines of code were supposed to do? So you're just you were recreating it line by line, and you make sure every goddamn line you write is doing what it's supposed to do as you go. You're a programmer, like I said, you're conservative in deleting. You don't want to delete code, right? You want to keep your hands on all your, fine, you comment every line out. You uncomment out lines one at a time and run and make sure everything acts the way it should. So the strategy is like comment out every line. Obviously, it's not going to do anything. Uncomment out a logical unit of code and run it. This should only be a line or 2 of code. Maybe add a print to make sure it's doing what you think it is. Did it do what you expect? No? Oh. Yes? Keep going. You may realize this is effectively recommending. You may realize, like if you go back a couple weeks, a month or so ago, this is how I tell you to write your code in the first place. Write a few lines. Does it do what it's supposed to? Write a few more lines. Does it do what it's supposed to? Test along the way as you're writing your code. That's effectively what this is, except it's kind of conceding the fact that you screwed up, and you got to go back and kind of try that again. So that's another good strategy. Anyone ever hear this one? Rubber duck debugging. You want to know what it is? You grab a rubber duck and you explain your code to the duck. That's it. I'm not joking. This is a real thing, and it's shockingly effective. Because first of all, it slows you down. Like if you don't have a rubber duck, get a teddy bear. If you don't have a teddy bear, get your mom. I don't know. Your mom's going, I don't know what that, it doesn't matter, Mom. I just need you to listen to me. You explain the code. It's going to slow you down. And like I said before, it always goes the same way. Okay, on this line of code, we are adding these 2 variables together because it's important. Yada, yada, yada. And then down here, we're going to loop over from everything to the sum. Oh. It slows you down. You have to like audiate all of your ideas, which slows you down. And it lets your brain keep up with your brain, which is a very good thing when writing code. This is not a joke. Rubber duck debugging works really well. There's a real wiki article about it. Look at the duck. All right? There you go. Look at that. See? I don't know what year this is. You can tell this is old. But and there's another duck back there too. Just in case the first one doesn't work, they have a backup. Rubber duck debugging. It's a real thing. Any questions about any of this? Yeah. I will usually not necessarily use a duck, but I will usually talk to another human being when I get really stuck. And I have no expectations. In fact, I don't want the other human being to give me any thoughts or input because they don't understand what the hell I was doing. I just need something there to listen to me. Other questions? Gotta check. We used to have little ducks to give out at this stage, but I can't remember. Yeah. I don't think we have them anymore. I know. All right. FileIO. All right. We know how to read input from the user. We've got that input function, which we don't really use very often, but we do have it. We know how to store data in variables. We know how to manipulate data. The trouble is, if I were to say, here is a giant amount of data, it's like 100 lines long. Here's the list of all the Starbucks locations in North America, for example. And I say, okay, now load them in with input. You're going to go, no, I'm not going to do that. That's ridiculous. If we have large amounts of information, we need a quick and easy way to load data into the programming language, or into your program so you can start playing around with it. And this is where file input and output come into play. Fortunately, Python makes this rather straightforward. It's one of like the whole selling points of Python is this, it's a scripting language, it's easy to load in data and whatnot. So text files are a great way to store textual data. Go figure. Typically, these files have a .exe, not exe, txt on your computer. But by the way, the file extension doesn't matter. The file extension is just there for your computer as a hint for like what program would open this file. But it doesn't really matter. Well, I'll show you an example. Oh. I'm going to go here. New text document. Some .thing. This is a .thing file. My computer's going to be like, I don't know what that is, but that doesn't really matter. Because I could open this .thing file. Maybe I can't. There. I've opened it in a basic text editor. There. There we go. Cool. Great. I can close it. I can reopen it. There we go. It's still just text stored in that file. The file extension doesn't really matter. But to follow conventions, I really should have this. Nope. I really should call it a txt file. So anyways, I could open up. It's still a text file. It's still a text file. Cool? Cool. Most of what we're about to see will work on many different file types too, not just text files, by the way. But anyways, reading from a text file. All right. So I've got some file on my computer, and I want my program to be able to access and read the information from that file. So how do I do that? Well, there are a few ways to open up a text file. First thing we got to do, though, is in Colab. Remember how in assignment 1, you needed to be able to, you had to upload the file to Colab first so it would know what's going on? Well, we have to do that here. Let's see, refresh. Did I not upload it? What did I do wrong? There we go. Maybe? What's going on? Why is it? Come on. Warning, yes, okay. Okay, there we go. Cool. And I can open this here and we can see it's just a text file. Now, the only reason we can load, we have access to this is because I gave it to Colab, so it knows it's there. It's a file, and it's in the working directory. It's a whole thing. But there we go. That's the file. Now, if I want to load it, I can just use my file, open, the name of the file, and then I have to do this thing right here. There. The R means we're opening it in read mode. I'm not going to write to this file. I'm just going to read the information from this file. And that's nice. It gives us some control, so maybe we don't accidentally write to it when we didn't want to. We only really wanted to read from it. So we've opened the file in read mode. And we can say, type of my file. Yep, it's this IO text IO wrapper, whatever. It's a file that I can read from. Did you bring enough for the whole class? That's not enough for the whole class. So we'll reference, so there we go. So yeah, let's do this activity real quick. Create a text file on your computer. Desktop's probably the easiest. upload it to Colab, and open your text file like in the above example, but with your proper file name, and then try using some of the built-in methods for that file object. And see if you can, figure out how to reread from the file after you've already the full contents. That's a good tricky question. So do this activity. I'll give you a few moments for this one. This is a good one. Raise your hand if you're done. Raise your hand if you're stuck on uploading it to Colab. Raise your hand if you're just still trying to figure out how to read from it. I'm confused then. Where are we stuck? Raise your hand if you're almost done. All right, okay, yeah, okay. Keep going, keep going. Here's what I got. I've got my file. We saw it. I opened it in read mode. I called the method myfile.read. I saved it in a variable called what is this. I printed out what is this, and I saw all of that. And, well, from the looks of it, it's a string. And how do I know? Well, I asked. And it's actually a single string of length 92. What's neat about this string is it's one string, but it's on multiple lines. But that's fine. There's nothing wrong with that. So it looks like read will read the whole file. So that's great. But we've got a couple of different methods we saw, right? So I can say like read line. What do you think read line does? Well, to me, it seems like, well, it just read one of the several lines, right? It'll read a whole line. And now in the previous example, I showed you that one thing that was on multiple lines. That was one string. But the strings had new lines in it. So like that new line was represented. Remember /n is the way to make a string go to another line. Now let me re-jog your memory. So like this is clearly one string, but it's appearing on two lines. Because I have this /n, which means like go to a new line. It's that special escape character. So read line. Okay, cool. I mean, I could do that a lot. Read line, read line, read line, read line. Oh, maybe I went too many. Oh no. Yeah, and then, cool. Cool. So read line, there's also a read lines. I mean, right now we're just playing around. Read lines. And it looks like we want to like specify how many lines. Let's read 4 lines. Maybe, 4, what? Maybe I'm using this wrong. Well, whatever. I'm clearly using this particular method wrong, but that doesn't matter too much. Point is, there's several methods. Now, what's interesting about these files is, okay, I've read 1, 2, 3, 4, 5, 6, 7, 8 lines total. And then you say to me, well, I want you to go back and read the first line again. I can't. I can't. Once the file like iterates, and it only can go in one direction. It read one line, then another line, then another line, and then another line, and then another line. And you say, go back, and it goes, I can't. I can only go that way. I can only go that way until I finish. Then you say, but I really want to. You can't. Does anyone have any solutions to this problem? There's 2 obvious ones, but they might be so obvious that they feel like stupid.
Close the file and open it again.
Just, reopen the file. Just start again. There. Read a line, read a line, read a line. It's like, imagine you had this little robot, and you're at the beginning, and it just reads, 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 and you tell that robot to go to the beginning. I can't. Well, just, let that robot fade into, oblivion, and create a new robot to start over, and it's going to just carry on fine. That's the idea. That's idea number 1. Any other ideas? To me, the simplest thing to do, this might feel like a trick question with a trick answer or something, I don't know. Just read everything, save it in the string, and then you can manipulate that string however you want. Well, you can't change it, but you can like interact, like you can get information from that string however you want. So you don't, it doesn't necessitate, oh, start reading the file from the beginning again. Just read everything, and now it's in a string, and you can do whatever you want with the string, because it's a string. It's not a file. Read line. And yes, it's also important to close your files. Now, not so much when reading from a file. When we're done with a file, we should be good programmers and we close the file. We close and we're good to go. Not that big of a deal when reading, but definitely a much bigger deal when writing. And we'll cover that in a moment. Any questions about, yes?
What's Unicode decode error?
That means that, what did you write your, so it means there's probably several, depending on the specifics of what you're doing, there might be a solution to that problem. What you could do is, this probably won't fix it, but I'm curious what will happen. Where you have W, change it to like WB in your, when you open the file, and then hit run. No, just this is what I mean. Just go here, or no, not W. No, sorry, not W, that's right, read. I want you to do RB. Try that. So I'm guessing, what's the extension of your file?
It's just some random file that I have on my computer.
So the problem is you're reading and it wants to read that data as a plain text data, right? So it's expecting, okay, the zeros and ones, they're going to mean like letters, right? But if you give it a file where it's not letters, it's going to go like, whoa, hold on, I can't read this as a string. So that's what you're seeing. If it was like a Microsoft Word, so sometimes, by the way, listen up. When I say make a text document, I do not mean open up Microsoft Word. That is not a text document. That is an entirely different thing. There's similar programs on Mac I'm not aware of, but like, yeah, that's not a text file. If you try to read it, it's not going to work. A text file, you need a basic text editor, something like Notepad, by the way. Other question. But yeah, so what you were seeing was it was going like, I can't decode this as a letter. And so when you did it, did you get like weird gibberish, like hieroglyphics? Yeah, it's trying. But it's, yeah, it can't. Because remember, all it is zeros and ones, and then it wants to decode those zeros and ones as letters. So based on what those zeros and ones are, this is the letter, and then you get some nonsense. Other questions? That was a fun question, though. Other questions? Now, writing to a file. Now, the file you write to, there's a couple of ways we can do this. The file you want to write to could already exist. But what do you want to do when you write to that file? Do you want to overwrite everything that's in that file already? Or do you want to append to it? I don't know. Maybe you want to write to a file that doesn't exist yet. Well, what do? Well, these are all questions that we as a programmer have control over. I'm not going to get into the details of all of them. But these are things that we can do. You can write append, you can create a new file if it doesn't exist. It's entirely fine. So here's what I'm going to do. I'm going to say my file equals something else dot text, but I'm going to open it in write mode. And I'm going to hit run. I'm not going to do anything, but I'm going to hit run and watch what happens. I hit run. And you see nothing, but if I go over here, actually, I'm curious, I might still see nothing. Yeah, and it's probably never close the file. Oh, never mind, it popped up. There we go. So I created a file, and then you can see it actually popped up in the working directory over there, something else.txt. Now if I go to it, there's nothing in there. It's empty. All right, that's fine. Now we could delete this for fun. Yeah, delete. So if I want to write to a file, what do you think we're going to say? My file dot write. Looks pretty good. Write. What do we want to write? Give me a string. I modified it a little bit. I know. Now, based on what you see here, well, we'll see. Okay, I'm going to hit run. Okay, nope, there we go. Popped up, open it up, and we can see there's nothing in the file. That probably didn't meet your expectations, did it? If we wrote to that file, shouldn't it be there? What's going on? What's up? Those function, that's just because of this here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That method, when you call it, it actually returns a value. And the value that's returned is the number of characters that were written. Why? Whatever, it does. Now, this is Colab, and do you remember, if there's ever a value that's like returned and floating around in Colab that you don't do anything with, Colab goes here. So that's why we saw 22 printed. It wasn't printed, it's just, it was shown to us. And I can demonstrate that with now there was no 22, right? Because it wasn't on the last line. Anyways, I hit run, I hit run, I hit run, and like, there, oh, okay, it worked that time, that's interesting. We got lucky, okay? Notice there's no new line, so if I wanted a new line, I need like a new line there. So I go here and we can, but you know, it never added that new line. What's going on? I'm writing to this file and it doesn't seem to be updating when it should be. That's because I never closed my file. Really, it's because I never flushed the buffer. But closing the file will flush the buffer for you. Long story short, whenever you're writing to a file, always, 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 when you're done with that file, close it. And I'm speaking from experience on beating my head against the keyboard for God knows how long over issues of the whole issue was because I never closed the file and flushed the buffer. Here's why. Let me show you this first, and then I'll make clear why this is important. Let me just, there we go. Come on, come on, come on. Why is it not working? Uh-oh, I made myself a liar. Didn't I add a new line there? What's going on? Let me delete this and try running. The issue would persist even though it looks like it did. Just go with me. There, okay, yeah, for real this time. So here's the problem. It turns out, let me show you something here. There. I'm hitting run. We can see this is taking a little while. I said loop 2, what is that? 1, 2, 3, 1, 2, 3. I said loop to 1,000,000. And it's still running, and now it's done. That took 15 seconds to run. We can see that. Do you really think it takes a computer, a modern computer, 15 seconds to count to 1,000,000? No. What does take 15 seconds is printing. Printing is very slow. And let me show you. I'm not going to print. I'm just going to like z equals 0, z plus equals I. There. Wait, does that make sense? Ah, because we printed out I. We need to print out Z. It took 0 seconds to run as far as Python's concerned. So we were able to loop 1,000,000 times a lot faster if we didn't print it out. Turns out FileIO is slow. So to make it not that painful, what we do is we create a buffer. Instead of, if I say if I have a program that has like 15 million write to a files in it, and that file is super important, instead of going and being like, write to the file, okay, take that information, go to the file over here, there we go, go back, oh, write to the file, okay, go, there we go. Instead of doing that, what it does, because that's very slow, instead of doing 1,000,000 writes, what it'll do is it'll put each write into a buffer. A buffer is a fancy way to say like limbo. But it's remembering, imagine it's like a big string. It adds it to a big string. We're not writing it, it's just saved in the computer. And every time I write to that buffer. Then, every once in a while, when that buffer gets big, Python will flush the buffer, meaning it'll go from take the information in the buffer and then go and do a write to the file. So instead of having 1,000,000 writes that are very slow, we do 1,000,000 buffer updates that are very fast and one write that's very slow. Doing one big write doesn't take very much long, like does not take a lot longer than doing one very little write. It's the process of writing to a file that's slow. So if we don't close the file and we open it, we might be in the situation where the buffer never got flushed. The number of times I've written code with like hundreds of thousands of lines of information in it, and the last chunk of data is missing because I forgot to close the file or I forgot to flush the buffer, is far too high. I shouldn't admit it. Like, always close your file. Long story short, writing is slow in the same way that printing is slow. It's slow. So don't print a lot, print once. Just print a lot of information once. That's fast. As opposed to doing like 1,000,000 little writes. Any questions about that? Writing to a text file, yeah, okay. Always close, cool. All right, we'll pick up here on whatever.